Hello, and welcome to this hands-on demo session. So we are going to walk through a complete end-to-end machine learning data workflow using Amazon SageMaker. Now, before we touch on any tools, let me explain what you are really trying to solve, because understanding the business problem makes the technical decision make more sense. We are going to work with a customer churn data set. And a churn simply means a customer leaving. When we say a customer churned, it means they canceled their subscription, maybe stopped using the service or switched to a competitor. And for any business, this is very expensive. It's far more to acquire a new customer than to keep an existing one. So if you can predict which customers are likely to leave before they actually do, the business can step in, maybe offer a discount, improve the experience, reach out to this customer, and potentially save that relationship. And that is what this data set is for. The churn column is our target. That's what you're trying to predict. Now, every other column that you have in our data is going to give us a clue to help us answer one question. Is this customer, about to leave? So yeah, we're going to take the raw messy data, clean it, engineer powerful features from it, and then package it into a reusable automated pipeline. So the first part one, we need to get our data into AWS, and SageMaker works with data stored in S3 among other solutions as well. Amazon S3 is where we're going to start. So with the console, let me just go to the console, and you're going to create a bucket and give it a descriptive name, something like labs Chandam, and create. So remember, packet names have to be globally unique. So if that name is taken, just add some numbers to the end. And once this is created, I'm going to create a folder structure just to arrange everything in a simple manner. So create folder. And inside this folder, I'm also going to create a couple of folders, one for our raw data, so raw, and the other for processed data. Okay, so I'll load our file into the raw folder. And awesome. So then that's the starting point, the raw data. So the second part of this is setting up data wrangler. So I'm going to open SageMaker Studio, and then just make sure you're in the same region where your SageMaker domain is set up. Otherwise, you're going to see your resources. So Data Wrangler is just a visual data preparation tool, helping us clean, transform, and then engineer features without writing a lot of code. But it also gives us the option to drop into Python if we need to. So let's go and set up Data Wrangler. So that's under SageMaker AI. Okay, when you get to this page, if you have not set up Easy before, you need a domain. So if this is the first time, I have a domain set up, but you can go ahead, create a domain, and you just see setup for single user and setup, simple as that. And after that, Wrangler is under Canvas. So you would go Canvas, and then we open Canvas, and it's gonna open this for us. It actually takes a few minutes, so I am going to pause this video and come back when it's loaded. Okay, that took a minute or less. So here you can see Data Wrangler. So we are going to go there, and the first step is to import our data. So this is a CSV file. You select a data source. There are multiple options that you have available. You can just go through them. So mine is Amazon S3. Here is my bucket, ML Labs, and under row, here I have my data set. Okay, so we can already have some views. I am sure the first row has been treated as a header, and then we have the customer ID, some of the other columns available, and also here the churn, our target, what you're predicting. So even at a glance of this file, you could already start spotting some issues. For example, a negative value for Kenyaman, you're missing the age, and so on. Yeah. So you can also say we have a negative age here. But instead of eyeballing this, we're going to let Data Wrangler find these issues for us. So let me select this data set. Next. And import. So next stage is to do an analysis of our data. So we're going to do the data quality and insights report and just try to figure out what issues does our data have, is it okay, and so on. So we're going to get some findings with regards to things like missing values, outliers, if we have invalid values in our data sets, if we have duplicates in our data set as well. So back. So under here, we can go ahead and just say get data insights, and it's going to generate a report for us. So I'll just, the target column is churn. Okay, and yep, let's go ahead. Okay, so my report is complete, and yeah, Data Wrangler does the detective work for you. So we can see let's take a look at, what is here. We can see we have 11 features that is just related to the columns, 50 rows. We have some missing values, 98% of valid values, and we also have some duplicate rows in this case. And we can scroll down and get more information on this. For example, 8% of the data are duplicate. We can see some of the features and which features are better for predicting the churn. So we can see like the tenure months has like a higher prediction value compared to others. And we'll just have a discussion on it. Which features do you think, are better at predicting this? Age also is a factor, but as you can see, the customer ID maybe payment method is not really a big factor or does not have a high prediction power to churn. So apart from that, we have some duplicate rows, and we also see the rows themselves. We have some samples which are anomalous as well. And yeah, we gain a lot of information that can help us, make a decision. So that is with regards to the data quality and insight reports. So now that we know some of the, issues which are being faced in our data, we're going to move ahead into the lab preparation phase. So the first part where we try to clean our workflow in terms of missing age, what do we do about it? If we have some invalid ages, like we saw we had a -5 for an age, how do we remove that as well? By tenure, we are going to drop duplicates and so the first thing that I'm going to do is impute the missing age, as you can see from step 1, and back over here. So we can go back to our data, and I'm going to add a transformation in this case. So yeah, I'm going to input the missing age value. As you can see, let's see, and under it, we have whose age is missing. And I am going to use handle missing values. So here it is, the transformation. To do that, the input to column is age. And then the input strategy. So we have a mean and median. I'm going to use median in this case. And why mean? Because we have an extreme outlier in, for example, monthly charges. Well, that doesn't directly affect the age. It's a good habit to always refer median in datasets with outliers, because the median is resistant to extreme values, but the mean is not. So, and this is important. I'm going to impute the age before filtering, because if I filter the negative edges first. I think we had a negative edge somewhere. Negative 5 here. Yeah. If I filter first, that also drop the row where the edge is blank. Okay. So by using first, I fill the other blank with the median, and then when the filter, we only remove the genuinely invalid row, this one which has negative 5. So let's preview. Okay. And now in the edge, you are not missing anything. So I'm going to add that. And then the next transformation, I'm going to filter the invalid edge. So I can go ahead and manage row, filter. The column name is edge. The condition is only edges that are greater. Or I can just say greater or equal to 0. And now one row is removed. Add. So the next thing as well. So I'm going to filter the invalid tenure. We had the tenure months here. And you can see we have some value which is literally negative 1. So I'm going to add a transformation as well. Filter. Tenure condition should be greater or equal to 0. And also one row is going to be removed. So I add that as well. And then you can include the remaining numeric missing values. So add a handle missing, impute, and the other columns that we had available. So things like monthly charges. So we can see we have some missing values as well over there. So we had the monthly charges, the total charges. And then we are going to import with the approximate median as well. But these columns are numeric. So I'm going to add that. And then I'm going to add another for the categorical missing value. So now the other columns, like let's say contract type. So here, like this also are strings basically. The contract type, we see some missing values for the internet service as well. So that will go under categorical, and we can impute the columns. So that is contract type. And then we had, let's see, internet service and payment method. Okay, just a minute. Okay, so we add the transform, handle missing, impute the categorical. The columns are contract type, the internet service, and the payment method. And here we do not have an option in this case. So data automatically uses the most frequent for categoricals. So for example, under contract type, let's say, so if the majority is month to month, it will impute with that. Okay. In the internet service, if DSL is the most frequent, it's going to choose that. So I'm going to add this. We can go ahead and remove the duplicates. So add, manage, drop duplicates. Let's preview. So we had 2 duplicates that was removed as well. And then we can do some one word encode. So in this case, encoding has a way, for example, if we say the gender, this works for categorical colors. So in the gender, we have male and female, but remember our models understand in terms of numbers, maybe 0 or 1. So if we do encoding in this case, we are trying to change these strings into numbers in such a way that our model can understand. For example, we could either say gender is either male or female. If it's male, 1. If it's not male, 0. So that is what we're going to do. So I'm going to choose encode, category code, and then we do one more time code, the input columns. So let's see, we have gender, we have the contract type, internet service as well, payment method. Okay, so that's it. And then under advanced, we'll choose the output style is columns. So let's preview. And you can see, so for example, if a contract month is month to month, it's a 1. If not, it's a 0, but it will probably fall under somewhere else. Another one we can take a look at. Let's see the gender. So one wanted it created 2 more columns. So if it's female, you get a 1, not female, 0, but the male is going to get a 1. So that looks good. We go ahead and add that. So another feature that we could possibly do, because some numbers are really huge in this case, we can go ahead and do some scaling to get values that are easier to predict. But I would like us to do the second step, which is feature engineering, so that we can do the scaling later once our data is ready, maybe for the model in this case. So that is the first step, the first part of the lab. After this, we can go ahead, take this as well and do some export. So you can go ahead, export this data to Amazon and have the clean version of it. So let me take that. Let me just show the scaling transformation. Let's start. And so I transform. And now the last one is scale. So we want to scale values, and then we can input the columns where we want to scale as well. For example, let's see the tenure. We can do a scale on this so that we have values which are 0 to 1 in that case. Let me just show an example, for example, for the tenure max and do a preview. Review that. So now the scale comes from 0 to 1. So even the graphs look like, something you can understand instead of having. If you have numbers which are like millions, you can do a scale of those numbers to reduce them. So, make the prediction better as well. So I'm not going to add the scale as well. And after you have done that, maybe you added your scale, you can go ahead and export your data to Amazon. You can choose the location as well. So in our case, we can now choose this to process, and maybe have a clean, location in this case. So let me cancel, and I can put my S3 location as well. So for example, my packet. So I can copy the URL for that. So something like that. And then under here, instead of row, we say, for example, the processed folder. And here we can have like the clean dataset version of it, like Churn clean. And yeah, just as simple as that. And it's Okay, so let's take a look at our bucket again. So now we have processed, and when we refresh this, you can see the churn cleaned, and we are going to have our clean CSV in this case. So let's move to the second part where we do the feature engineering. Now that the data is clean, we have encoded, we move to feature engineering. Cleaning gets our data ready, but if we engineer our features correctly, that is what makes it powerful. So just an overview of this as well. We have the row columns. The row columns are very useful, like the age, the tenure months, and so on. But you can create new columns that tell a richer story about our customer behavior. So that is what feature engineering is about. Now, we are engineering features which will have a more predictive power than the raw numbers. So you can see, for example, here the explanation. So revenue generated of a customer history. So high value customers are priority for retention. So we can do a underscore of that. We can do some, engineer to check like if the customer is predicted to be a long-term customer. And this is like a binary indicator, 0 or 1. For example, customers who are here more than 2 years are more loyal and typically churn less often. Things like high monthly charge, customers who are on expensive plans might churn. So these columns that we don't have already, but we can engineer them. And that's what we're going to do in this second part. So back here. And I'm just going to continue from this place and add a transform. So we are going to add a transform, and in this case, you are going to use a custom formula. So a custom transform in this case. So the name of this custom transform, so we can say the values, and I'm going to use pandas. You can use any. But so you can see this is ideal for smaller data sets like our and experimentation. But if you're using a production business use case, you can go for PySpark in this case as well. So all these are available. So for example, the first part, you can see the value score is 10 times the monthly charges. So I'm going to get that. Okay, actually, before we do this, we need to do something, okay? We need to remove the outliers in this case. For example, if we check here under the monthly charges, we can see majority of the charges look okay, but you have, one outlier at the very end. And this is the customers whose all orders are being charged like few dollars, this customer is being charged 999. So because all features are like the value score, we multiply like the tenure by the monthly charges. If we still have this number 999 in the data, and when we create that feature, it will actually produce a very big value that is going to skew everything. So removing this outlier before building features, we need to remove it before we build features that depend on it. So allow me to remove that outlier first. So monthly charges of layers. Let's see. Remove it. Okay, just call it remove outlier. So okay. That's that. 10 with the format. So anything where the monthly charges should have like less than 200 like previous. And now one in the columns is going to be removed as well. So I'm going to add that transform to our data set, and now go ahead and do the computations. So let's go ahead and create the engineered features. So let's see. Feature engineering. Sorry, I chose a custom formula instead of a custom transform. Feature engineer. And then I'll still use pandas, and I'm going to copy a couple of commands. So all these commands, let's see what they do. So of course, the first one, the value score, this approximates the customer lifetime value. How much revenue this customer has generated. Its long-term is a binary flag. So 2 years is a natural loyalty threshold. So we expect long-term customers to churn less. High monthly charge, in this case, flags customers on expensive plans. For example, those who are paying more than $80 a month, they might churn if they feel they're not getting value for their money. We do have the average charge ratio in this case, which is going to divide the total charges by the tenure and is going to give us the average billed amount per month over the customer's, lifetime. Okay, so, and then we have the ticket intensity in this case. So we are going to divide the support tickets by the tenure. And a customer who has raised like 5 tickets in 2 months is very different from one who has raised 5 tickets, over 5 years. So this is also going to capture things like service friction related to how long they have been a customer. So let's review this as well. And we have our new columns generated for us. High monthly charge is long term, 1 or 0, ticket intensity, and so on. So that looks good. I'm going to add that as well. Okay. And the next step is to bin age. So why bin age? Because the relationship between age and, the churn is not always linear. So if we group similar ages together, it's going to reduce the noise and make the model more robust in our case. So let me check if I have the command. So over here in the age band, so it captures an nonlinear relationships between the age. So I'm going to copy my command and let's add a feature, add a transform customer. So you can see, over here, I'm importing pandas explicitly because that Wrangler doesn't support it automatically. You're going to get an if you forget. So we want to just be these ages because, customers between 18 and maybe 29 are going to behave the same way. So the name, in this case, just binage. Okay, let's preview. And now we can see if a customer is between the age of 30 to 44, 45 to 59, 60 plus, and so on. So looks good. We go ahead and add that. The other step that we need to do is to drop our customer ID. And a customer ID, like looking at it, is just an identifier. Okay, it has no predictive value. So means the model is going to learn some meaningless patterns from it. So always drop our identifiers before modeling in this case. So that is a simple step. I'm going to add a transform and then I'm just going to manage columns and drop it. Okay. So I'm going to drop the customer ID. Preview. So one column is off, add. And now I was talking about scaling. So scaling is the very last step in this case, and this is deliberate because all our engineered features were created using the original values. So if we had scaled it fast at the first time, the tenure months would be between 0 and 1, and the threshold of like a customer stayed with us for 24 months will never trigger. So these features will be completely wrong if we scale it fast. So I rather to always scale last just before going towards the training of the model. So I'm going to use the min-max scaling. Min-max scaling compresses all values into 0 to 1 range. So no single column like dominated the model because it has really higher numbers. So now I'm going to add the scale under process numeric. So scaling values, min-max scalars. So it will rescale the columns to 0 from 0 to 1 basically. So I'm going to apply this to, for example, age. Let's see what we have as well. So the tenure months, monthly charges, monthly charges, support tickets, and the total charges. Where is it? Not that one. Okay. So these are the values which have like, a lot of numeric values that would like to scale as well. So let's preview. And now you can see for the months, the monthly charges, now we are left from values 0 to 1. So it does not, so no columns have, dominate the model. So I'm going to add that as well. And at this point in time, we can move to the pipeline. And I'm going to pause and ask you something. There is no single right answer. So looking at these data sets that we have available, we have the features that we have created. Which factors do you think matter most for predicting the churn? Is it short tenure, month-to-month contracts, and so on? So think about it from a customer's perspective. Someone on a month-to-month contract has no commitment. They can leave anytime with no penalty. Someone with short tenure is still in that early phase where they haven't fully committed. Someone paying high monthly charges might start questioning whether they're getting their money worth. All these are valid signals. So we don't need to prove it statistically right now. The model will do that. So the goal was to reason about the data like a business person, And just take a moment and think about it. So we are going to move to the final part of this. So we have done the feature engineering. Here is the discussion prompt. We want to make this usable. We don't want to go out and keep viewing this data wrangler. So write our flow lives in data wrangler, and every time we get new data, we'd have her automatically not automatically, but manually learn through these steps again, and that is not scalable. So our pipeline package is good because it packages all this logic so it can run automatically on any new data without rebuilding anything. So in this step, we are going to export the flow now not to S3. I showed you how to export your data to S3, but export the flow as a SageMaker pipeline, which is going to generate a notebook. And that notebook will contain all our transforms, like the cleaning step, every engineered feature, the encoding, the scaling. So it's going to package that as a Python code that SageMaker can execute. So let's go ahead and do that as well. So back here under the data flow. So now we can go ahead and export this. So export via Jupyter notebook and then SageMaker pipeline. Okay. So let's get a URI. And then I can, create a folder called output. Okay, so that is exported as well. So we can go ahead and review our notebook. After exporting to S3, you can see under ML Labs, under the output, we do have some objects available, and we do have the notebook file that is available over here. So if you want to work with these notebook files, and Amazon SageMaker Studio back over here, you're just going now not on Canvas, but on SageMaker Studio. You can go ahead and click Open Studio. And you'll be redirected to this specific page. So to draw our notebooks, you can go ahead and use Jupyter Lab. If you don't have instance running, you can just create one. You'll be prompted to create one. So you can go ahead and open that, and you'll basically be taken to such an environment like an IDE you can use. So you use a specific environment. You can run a command to copy the notebook from Amazon S3. This notebook, Jupyter notebook, so you can run it as well. So you can see the command S3, copy the file, and only include these specific files from my specific bucket. And it was able to download that specific file, which is available over here. So now this notebook contains all the commands that you specifically need to run. So the whole pipeline itself. So creating the SageMaker pipeline, it has all the information that you need, all the installations that you need. So we install SageMaker. You go ahead and configure some settings. You specify where the source is, the source of the data set. You specify where is the output of that specific data set as well, the S3 location, and then you go ahead and create the processor job. So one thing that I'd like you to note is for the instance type that is going to be requested for, in case you do not have access to that, and I'm speaking about this because at the very end, you can see the error that is generated, that this processing job could not be generated because I basically have a service quota limit. So in such a case, that is not a big deal. You can go ahead to Amazon SageMaker. You can search for Amazon SageMaker under service quotas. So click service quotas, you can search for Amazon SageMaker and search for processing jobs. So you'll get a list of some of the instances that you have access to. And here are some, you can change to any of these, but you might also face some challenges with them not being compatible with the container image that is generated. So no worry about that. You can come here, select a specific instance type, and request an increase at the account level, and you can specify the quota value as well. So in my case, you can say I've submitted a request. It might take 24 to 48 hours for this. Okay, but back to this specific notebook. So we now defining our pipeline. Remember, all this was generated for us. It defined all the things needed, the output location, the instance type for the processing job, the instance count for the processing job. So that is what is related to the service quotas as well. You can check the pipeline definition on all the things that are needed, the input path, and also the output configuration as well. And you're going to submit the pipeline to SageMaker, start the execution, and wait. So this is basically the last step. I am going to share a very short video on the expected output once my quota increase is approved. But basically, that's it, and it's going to do everything that we have set up in Data Wrangler. When you come to SageMaker AI, you can actually, under data preparation, see the processing jobs that have been done with the notebook that we have created. And now after that, you can go ahead and figure out triggers, like what triggers the notebook to run, and automate this whole process. So that's specifically it. When the job completes, so just go back to Amazon S3 and validate the output. Yeah, confirm the output, confirm the row count. We can open, so this is the file, so it should be under processed. Oh, okay. So it should be under processed once the whole process is over. So it will be basically coming back over here. So I can add an export as well. And then the SRE location now based on the notebook, not here. So this is just a console overview of it. So based on the notebook, we can specify a different folder as well, like churn processed or something. Well, featured, yeah, featured makes sense. Copy the URI. And yeah, so this is what the output will be expected to look like once you have, run the notebook file. So a short video will be incoming on what happens after the SageMaker notebook runs the pipeline on its own. You can see the processing jobs. You can see the pipeline itself as well. So under here, you'll have an overview of the pipelines that you have created. You can see the pipeline flow and troubleshoot any issues that have happened. So thank you so much and see you in the next one.